Hello everyone, this is the Mining Geologist and I'm back again with another very exciting and very informative tutorial. In this tutorial, I'm going to show you another tool that I've created. This tool is available online for free, so anyone can use it freely. All you have to do is to navigate to the website drilleda.streamlit.app. Obviously, it is a Streamlit application and it's hosted on the cloud on the community cloud of Streamlit, which is free. So the downside of that is that there are some limited resources allocated to this app. So if thousands of you are going to use this at the same time, it's going to be slow. So the good thing is that if you are a Patreon supporter and you support this channel, you can download the source code of this app and you can run this locally. So all you have to do is to click on this one and it will take you to that page, which is this one. You can download the source code and run this application locally, so you will be the only one using that. So that's also one way to support this channel. You can also support the channel by clicking on the join button here, and you will have access to some members only videos that I don't share with anyone. These are for just VIP people that would like to support the channel and get something in exchange. So with that being out of the way, let's take a look at this tool. So this tool is going to be helpful when you're creating your geological model. Sometimes you get this data set with a lot of lithologies that you don't know what are these, and you've got like grades, but usually what you do is that you need to import this to inside a software, your favorite geological modeling software, and then you will be comparing the geology with the assay data and see what is the lithology that could be, what is the mineralized lithology. And some tools, they have options to like create combined tables where you can combine two different tables, let's say assay with lithology, and then check these easily. Some softwares, they don't have that option. So if you don't have that option, or maybe you don't have the software and you want to check your data, this is a great tool to start with. So let's take a look how it works. So you have the option. So in this tool, we don't talk about coordinates. So the data is not going to be desurveyed. Basically, we're going to compare two different tables without coordinates, which are the lithology table and the assay table. Let's go and take a look at an example. So you need to import your lithology table, or maybe the geology table here. You need to import also your sample table or your assay table. And one thing to mention here before I forget, you're not uploading this anywhere in the cloud. So Streamlit application or this Streamlit application is running like a JavaScript code in your browser. So it's looking at the data on your computer. So you're not sharing your data with me or with anyone else. So you don't have to worry about using this with confidential data. You're not sharing it with any third-party companies or anything like that. So don't worry on that side. And of course, with just 1 GB of storage or RAM, of course, I cannot store everyone's data, so that's not possible technically. So you don't have to worry about using confidential data. And if you're worried about that, you can actually download the app and run this locally on your computer, and it's going to run the same way because it's using the browser to compute this data. So let's take a look at how this one works. So the first thing that you need to do is you need to pick few columns. So what is the whole ID column for the lithology? It's going to be the whole ID. Then the from, it's the from. The to is the depth to. The lithology column is going to be this rock column. And then for the whole ID for the assay table, it's going to be whole ID from, and then this is the to. right away it's going to start to display things for us. So what you will see now is that we've got total unique hole IDs in the geology table is 94, and then also I have 94 in the assay table. I've got no missing holes for both geology and assay table. And then I'll be able to see the original table as is. I can also see the assay table. And any of these tables, you can actually click on this download button and you will be able to download the table. And I can pick here the main attribute. So in our case, it's going to be the grade. It usually is the grade. So I'm going to show you in a moment what this one is doing. So if I pick gold here, which is the only available one except for I have also access to the sample ID, but that's not a numeric field. So I need a numeric field here to use that for what's to follow. So the next thing you'll see that I've got a combined table. So now this tool combined both of these intervals and it creates like different samples based on the shortest sample between the two tables. So for example, if I have like from 0 to 2, that's the first sample and this first hole, then the same thing for the assay. So let's say that the first one is from 0 to 1 and it's from, or maybe let's take a look at the, at this one, the ST lithology, which is between 6 and 15.4. So you can see from 6 all the way to 15.4, we've got different grades. So what this one do in the combined table, you can see that it will assign the same lithology for that all the way to 15.4, but we've got like different grades. So this one is basically going to combine the two tables in a way that you will have access to both the lithologies and the assay data. If you have multiple, let's say, attributes or numerical fields, that will be also added to the combined table. You can download the combined table if you want and use that in your favorite software with the color and survey data, and you will be able to get that if your software does not do these this kind of combination. What you can also do is you can specify a cutoff. Let's say our cutoff grade is 1 gram per ton, let's say. So everything above 1 gram or equal to 1 gram, that's going to be considered as ore, and everything below that is probably, let's say, it is waste. So the way it works is that you select your numeric field. In our case, it's going to be gold. And I set up the cutoff grade for this numeric field to be 1. And then what the software or what the script is going to do, it's going to show me the possible ore based on the average grade. So now it's calculating the average grade in each one of these lithologies. And you can see that the average grade for the gold in this IN lithology is 9.15, which is above the average grade. So this one could be a possible ore or a possible mineralized lithology. And then I can check different statistics, like how many samples. You can see that we don't have that many samples in this one. And you can see like the mean, I can see the minimum, the maximum, and so on. So the maximum is 79. The minimum is above the cutoff. And I can also check that I've got this one with an average of 4 grams per ton. And then for the possible waste, you can see these are possible waste. Or maybe this one, it's exactly 1. That's weird. So you can check this one and you can either put this. So this is just to give you an idea like where the mineralization could be. So it's a good starting point. So you know that these are mineralized and these are probably not that much. So it gives you a really great idea. Now what I can do also is I can go to the visualization and I have access to other tools. So I have access to scatter plot, so I can choose a scatter plot. I can, unfortunately, in this database or in this assay table, we have only gold. But what I can do is I can create a scatter plot between two different attributes, let's say gold and copper, and see the correlation between these two. So I can set the gold, let's say, on the x-axis, but just for demonstration purposes, since we don't have any other numeric attribute, I'm going to say like 2. So it's going to be between gold and 2. Now what this one is going to create, it's going to create a scatter plot with the gold on the x-axis and the 2 on the y-axis. You can imagine that this one is another attribute. So also you can see that I've got that scatter plot, and I also have access to different tools to format or customize the display of this chart. For example, I can change the dot size if I want this dot to be a little bit bigger or smaller, so I can move the dot size. I can change the color to whatever I want. So let's say I want this to be blue. I can also change the number of ticks on the x-axis. Maybe I want more grades in the bottom here, and I can change the same thing for the y-axis. So I can also change the font size. So it's set to 12 by default, but you can change this to be smaller if you want. And then if you think you've added a lot of ticks and you need to rotate the text, you can rotate the text. Now the rotation is set to 0 by default, but you can set that to like 45 degrees or 90 degrees if you want. And then if you don't like the title here, so now it's saying 2 versus gold, you can easily change the title here and it's going to update that for you. So this is a scatter plot. It's a good starting point also to see the correlation between your data, but you can also apply filters. So let's say I want to filter by not the ID, but I want to filter by rock. So basically I want to see just one specific lithology. So when I change this one, it's gonna get all the unique values inside that rock field, and I will be able to filter by, let's see that IN lithology that we've got only like 68 samples. Let's see how these actually look. So I can filter by that, and if I'm filtering by a categorical column, I will have access to all the unique values inside that column. In this case, you can see these are the samples from that specific lithology. I can add multiple ones if I want. So maybe I want to see like IN and I don't know, like S2, for example. So I can do that. So it's going to display both of these lithologies. Maybe I want to see just the mineralized lithology. I can do that. Lithologies, I can do that. But what if I want to filter by a numeric field? So maybe I'm doing, let's say, comparing two different elements on X and Y, but I want to filter by a third element, so a numeric field. So I can, let's say in this case, since I have just this one, I can set the gold also as a filter. And when I change to a numeric field, the script is going to detect that automatically. And now I will have a slider with the minimum and the maximum of that numeric field. So you can see that the minimum is 0.01 and the maximum is 135. So what I can do is you can see that I've got values around here. So let's set this maybe to like around 60, and you will see that all the values above 60 are going to disappear because I'm using the gold as a filter. So that's also another filter that you can use to understand your data. This is going to update the chart based on that filter that we've added. And it will take some time based on how big is your data, and of course, like how many people are using this one, or like what are the resources allocated to this app. But in most of the cases, it should be fast. Okay, so we don't have access only to a scatter plot. We have access to two more features that we're going to see in a moment. Yeah, so this one is done. You can see that the maximum now is not exceeding that 60. So let's take a look at the second one, which is the histogram. So when you change the plot type, the features for that plot are going to be also updated. So we're going to have access to different kind of customization for the histogram. So I can choose a numeric field. In this case, the only one is going to be the gold. And then I can also apply filters the same way that I've done with the scatter plot. So I can see the histogram only of a specific lithology. So I've got the histogram here, but I can also maybe add the number of bins. So let's take this to like 80. And you can see that I will have like more bins here. So you can see that I've got more bins, but since this is a typical gold deposit, so I think the best way to look at this data is by doing a logarithmic scale. So this is going to apply a log scale to the data, and now we'll be able to see it better. So now I can see that I've got things around here. So the log scale is doing its job. I can also change the color if I want. I also have access to capping. So now you can see that the maximum is around here, which is maybe, I don't know, like 135 or something. So I can set this, maybe I will be capping at, I don't know, like 40. So I can set this to 40. And it's going to cap the data as 40. So everything above 40 is going to be now, it's going to change to 40. And that's how we apply the capping. And then we should see a bar around the 40 here. You can see that all of the data that we're above 40 now, it's equal to 40. So this is a great way to see the data. Like I mentioned, I can also choose a field, maybe rock, and I can choose you can see that I can check specific drill holes if I want to filter by ID, so that's also possible. But let's choose rock, which is the lithology field, and I can choose maybe this one, and this one. Let's see the histogram of all of these three. So this one now is gonna create the histogram with just the assay data or the gold samples inside these specific lithologies. So I can see the population maybe inside these three lithologies. So you can see that that's how the histogram looks. And yeah, I can change the color if I want. So yeah, the next thing is basically the box plot. So again, when I change the type of the plot, it is going to change the features that I can change. So now with a box plot, we will have access to different things. So I can choose the numeric field. In this case, I can choose the gold. And I can choose the categorical column. So I can choose rock here, but I can keep it by ID, which is basically going to plot like a box plot for every single drill hole, which is something that we don't want to see. So let's choose rock in this case, and you can see this was done by drill hole. These are the drill holes, and these are the box plots for each one of these drill holes. And log scale is applied by default, and this is going to help us see like outliers by lithology and so on. So you can see that I've got these box plots, and you can see that I've got the different lithologies here. But if I choose, for example, to see the drill holes, you'll see all the drill holes in here, or maybe I can choose specific drill holes if I want. So I can remove the log scale again, and since the data, like we've got a lot of values around 140 and 130, so you can see all the boxes are going to be around here, which is not a good way to see the data, but maybe you want to see like the extent of this lithology, where the data is, like the outliers and things like that. But I think the log scale is a good way to see this one. You can play around with the font size again. You can choose to fill the boxes or to infill them. I'm not sure if that feature is very useful or not, but it's there in case you want that. The circle size here, you can change this to like 1. These are going to be displayed as dots if you want that. And again, you have access to the same feature, like maybe you want to see specific lithologies. Maybe I want to see just these 3. It's going to show you the box. If you don't choose anything here, it's going to show you all the different lithologies. But if you choose to see just the specific lithologies, it's going to create box plots for just these 3 lithologies. So it's going to plot only these 3 that I've picked. And again, if you want to filter by a specific column, you also can do that. So maybe I want to set the gold, and this one is going to change. So if it's categorical data, you will be, it's going to display only categorical data. Maybe I want to see like specific lithologies, but I have another categorical data that I want to use it as a filter. You can do that way. If you have a numerical field, again, you can play around. You can see that the maximum extends to like 140 or whatever. For this one, it's going to be just, the maximum is going to be 6.7. So I can play around with these ones, and it's going to update the box plots. So these are the available visualization ways, but there will be more. I'll keep on updating this one and adding more features based on your requests. And of course, I'm going to update the code for people who are supporting the channel either on YouTube by joining the membership on the channel, or supporting the channel on Patreon. You will have access to the latest tools, but it's not it. There's another option that I would like to cover also. It's the combined lithologies. So for example, let's say that you have, I don't know, like 30 different kind of lithologies. When they did the logging in the field, they decided that this is, I don't know, like this is sand, and this is like sandy silt, and this is like clay, and this is like, I don't know, marl. So, but then when you're doing the modeling, this is gonna make your life really complicated, and I know how that works. So sometimes you tend to like combine multiple lithologies in just one lithology. That's also possible here. So I'm gonna show you how that works in a second. So this is the combined table. You can see, for example, that I've got, let's say that I want S2 and SH and ST to be all in just one lithology. So it should be going from 0 to maybe 15.4. So I can do that. So I can set this one. I just need one combined lithology, and I will add S2, SH, and ST, and I'm gonna call this maybe SSS. Okay, then once I'm happy with that, I can move down and click on Combine Lithologies. And what this one is going to do is, so this is the original lithology. So it's from 0 to 2 is S2, from 2 to 6 is SH, from 6 to 15.5 is ST. But with the combined lithology, since all of these are now called SSS, you can see from 0 to 15.4 it is SSS. And then it's gonna do that for the whole drill hole. And then also inside the combined table, it is going to do the same thing. Just keep something in your mind. I'm going to show you just a quick example here, that in case there's a hole missing in, let's say, in the assay table, and a hole missing in the lithology table, it's going to remove both of these in the combined table and what's shown in the original table. So that's how the tool works. I got an example that I'm going to show you in a second, with one hole missing from each one of these tables. So the script also handles that. It's going to show you that this hole is missing from this hole is missing from this, but it removes both of them. So you can see that now I've got this SSSS, and then of course split it by the assay table. So that's how it works. It goes all the way to 15.4, and you can see now that SSS is now like the descriptive statistics is calculated for the SSS as a whole. So now I don't have like separate lithologies. It's all inside this SSS one. I've got the statistics for the whole thing, and the same thing for the visualization. Now if you go to rock, you'll see that now I have SSS instead of all the others. They were removed, so I can do the visualization based on that SSS as a whole, a new lithology. So yeah, there's a lot of things that you can do with this tool, and based on your feedback, guys, I will be adding more features to this one. So one last thing that I would like to show you is in case of there's missing holes. So let me update or let's say I'm going to refresh this one. So if I go to, you can see that I've got the geology table with missing hole here, and I've got also the sample or the assay table with a missing hole. And then if I do the same thing, this is basically going to be the hole ID, this is going to be from, this is going to be to, this is going to be the lithology, this is going to be hole ID from, and this one is to, and this one is the gold, and so on. You can see that I've got one hole ID is missing from the geology table. Now I've got like 93 unique holes and 93 unique holes here. So WD004 is missing from this one, but another one is missing from the assay table. So this hole number 4 exists in the assay but not in the geology. This one exists in the assay but not in geology. So both of them will be removed. So you can see that it starts from 11, and the same thing for the combined drill holes. So both of these were removed from the script and the different tables that we have. Yeah, so this is the tool. Again, if you would like to support the channel, if you would like to download and use this locally, you can click on this one here, and if you can choose if you're going to be a Patreon, you'll have access to this source code and other things that I've shared on the channel. You can also join the channel by clicking on the join button here and choose however amount that you would like to support the channel with, and you'll have access to videos that I share only with members. And with that being said, I hope this tool is going to be useful for you. Let me know in the comments below, what should I add to this tool? What kind of things that you think should be part of this one? And with that being said, see you in the next video.